Hello everyone, my name is Rick Costello and welcome to the universe we live in, a spectacular universe that we are a part of and the ingredients that made us and the earth we live on. Well, in this show I'm going to show you things that are up in the night sky. In the last couple of shows we got into how stars are formed in nebulas, but this show I'm going to lighten things up a little bit and I'm going to show you the night sky and a lot of things that are up there that you can see with a pair of binoculars or a telescope if you have one. And just a lot of stuff to see. This time of year we're looking right into the center of the galaxy. And so just a lot to see up there. And so here I'm going to darken the sky, and as you see, we have a new moon, and this is actually July 20th, the day of the new moon. Once in a while the moon covers the sun, but right now it's going right over the sun. I think the next eclipse is going to be this December, but I don't believe it's going to be visible for us in the United States. I think we have to wait to 2024, I believe, is the next one for us. So here I'm going to let the sky rotate, and I'm going to let the sun set, and goodbye to the moon also. And there you see the comet. And this is Comet Neowise. Now, Comet Neowise has already gone around the sun, and now it's going back out into space. It originates from the Oort cloud, which is way beyond the Kuiper belt, beyond Neptune and Pluto there. And here I'm going to start moving. Every time the comet clicks here is going to be 24 hours, and it's going to show you where the comet moves throughout the next couple weeks. And they're expecting it to be visible at least till the end of the month, hopefully before that. And so that's where the comet is. Right now the comet's about 24 million miles away from us, or 26 million miles away from us, and moving away from us every day. And so here we are above the comet. We have the North Star, and there it is. Not the North Star, Ursa Major, I'm sorry. The Big Dipper. And it shows you the drawing there of the constellation. It's supposed to be a bear. Doesn't look like a bear, but it's okay. That's what they invented years ago. And so there's a lot of things to see around the Big Dipper, a lot of galaxies. And one of my favorites is M51. I showed you this, a couple pictures of this. Here we're going to zoom in on it. Now, M51, that's a galaxy. It's roughly about 23 million light years away from us. Again, if you multiply 23 million times 6 trillion, you get the mileage. It's incredibly far away from us. This galaxy is about 76,000 light years in diameter, smaller than our galaxy, and it's got maybe 10.3% of the mass of our Milky Way galaxy. And it's a beautiful galaxy. Now, that's the galaxy on the left there. You see a small one. That's actually, they think, maybe about 500 million years ago, came through and then went back out, and that's what's causing the spiral arms and the star formation. And I'm going to rotate it just slightly. Now, another galaxy up there is a giant spiral galaxy, and it's the galaxy M101. And here we're just going to straighten it out here, then we're going to zoom in on M101. And here it comes, and it's a beautiful galaxy to see through a telescope. Very faint, but still able to see it. And this galaxy is about 21 million light years away from us, and it's a giant galaxy. It's got a diameter of about 170,000 light years, and it's got about 1 trillion stars in it, and the spiral arms going, a lot of star formation going on in this galaxy. And we're going to zoom in out on this galaxy. And now, you see that bright star to the left of Andromeda, the Big Dipper there. If you follow the handle of the Big Dipper, it kind of leads you right over to that bright star. And that bright star is going to be the star Arcturus. And there's Arcturus. Arcturus is about 30 light years away from us. And it's a red giant star right now, and living its life. It's a little larger than the sun, and another great star. Now here we're going to zoom around to the star Viega. Now Viega, when the sun sets, is straight above you, the bright star straight above you. And that's the star that Jodie Foster went to in the movie Contact, for reference. And there's Viega right there. Now Viega is about 25 light years away. It's the 5th brightest star in our night sky. It's got the mass of about 2.1 times the mass of our sun. So it's a larger star than the sun. Very bright too, a very bright star. And the star Viega. Now Viega's in the constellation Lyra, a small constellation there, up in our night sky. And there's Viega there. Right next to Viega is a planetary nebula. And this is what's going to happen to our sun in about 5 billion years. And it's M57. And here we're going to zoom in on M57. And you should see the ring nebula. Now, our sun right now is fusing hydrogen to helium. It's about 26 million degrees in the core. Now, after the core turns to helium, it's going to start fusing the helium into carbon, and that's going to build the temperature up to about 100 million degrees. And that's going to cause the sun to expand. And over time, the sun's going to be so big as a red giant that the gravity from the core isn't going to be able to hold on to it. And the outer layers of the sun is basically just going to poof off. And that's what's happening here. It kind of makes a smoke ring. And in the middle of that ring is the remnants of the core, which is now a ball of a carbon and some oxygen. So let's zoom out on that. And another popular galaxy just below Lyra is the constellation Hercules. And there's Hercules right there, up in our night sky. Very nice galaxy, or constellation. A lot of things to see up here too. And these are a lot of things are the globular clusters, which are balls of hundreds of thousands to millions of stars. Almost looks like a baseball of stars. And there's M13 there. And we'll let that revolve around, and we'll zoom in on M13. And here it comes. And these are very cool to see through a telescope. As you see, it's like a baseball of hundreds of thousands of stars. They estimate there's about 300,000 stars in this. It's got a diameter of about 145 light years. And so those stars are really close to each other. They basically have a common center. They're all orbiting in different directions around there. And they get very close to each other, some of these stars. But very cool to see here. And it's the globular cluster. Don't wait for this to zoom out. And there it goes. And also in the Hercules is another globular cluster there. And this one's going to be M92, which should identify itself in a second. And there is M92, another globular cluster. And we'll just zoom in on this now. And here it comes at us. Now this globular cluster is about 26,000 light years away from us. About the same distance as the center of our galaxy. It's in that direction, but sitting above the plane of our galaxy. And this galaxy this globular cluster are very old. The stars in this galaxy are about 12 billion years old. Very old galaxy. There's no gases and gases or dust to make new stars, and there hasn't been for billions of years. And so now we're going to turn the galaxy a little bit, or turn our night sky, turn the planet. And there we go. And as you see, in the south right now is our Milky Way band. In the center of the galaxy, actually, is right over here. And we have a lot of things here. First thing we'll look at is the constellation Scorpio. Well, actually, we're going to look at I'll show you the whole Milky Way band there as it moves north to south. It basically stretches from the south all the way overhead to the northern horizon. And it's basically our galaxy, the spiral arm, looking right in towards the center, towards the south, as you see. And now we'll bring up the constellation Scorpio. And there's Scorpio there. It's just above the horizon. It's actually it's maybe about 15 degrees above the horizon. The top of Scorpio. And there's Scorpio there. As I take the constellation away, we're going to talk about the bright star. If you look, there's a red star right there, and that's Antares. Antares is a super red giant, and it's about 550 light years away from us. And in the visible light, it's about 10,000 times brighter than our sun. And it's a star that eventually is going to blow itself up in a supernova. Fairly... Now here, the next one we're going to show is the constellation Sagittarius. And there it is right now, the constellation. And Sagittarius the Teapot. Now after the Styx version goes away, you'll see the teapot right below there. There's a bunch of stars in the teapot. And I'm going to zoom in on it so you can see it right there. Just left of center right there. You see those 4, 5, 6, 7, 8 stars there. It makes a teapot over there. And that actually points right to the center of the galaxy. And so here are a lot of the Messier objects. Thomas Messier in the 1700s, he cataloged a lot of the stuff in the sky. As you see, there's a lot of globular clusters, open clusters, different nebulas around the center of the galaxy, in the direction of the center of the galaxy, to see up in the night sky with a telescope. Now, another object to look at is M8, which is a cloud of atoms, a nebula, and it's a giant interstellar cloud of gases and dust, and all the elements to make everything up to uranium, to make planets and everything. And a lot of most of those created in supernova. And a giant cloud, as you say here. And this thing's about 5,000 light years away from us. And again, a giant cloud of star-forming material. And here we'll zoom out. And we'll look at another planetary nebula next. And this is going to be M27, the Dumbbell Nebula. You've probably seen photographs of this. And again, a planetary nebula. And planetary nebula means it's like a star like ours. And basically, like I said before, it got large enough and basically the outer layers puffed off. And that's what this is here. Just so you're seeing the outer layers of this one star. And again, inside that is the core is a ball of carbon with some oxygen in it. And very cool to see these through a telescope. So let's zoom out here. And we're going to shift back to the sky here. Now, this time of year, this year I should say, not every year this summer, but all the planets are going to be up this summer. You'll see all the planets lined up towards the end of the summer, of August into September and even October, they're going to be up. And the first one we're going to look at here is the planet Jupiter. So let's center Jupiter. Now, Jupiter is the 5th planet from the Sun and our largest planet. It carries like 98% of the mass of all the planets. It's a giant planet, probably an iron core, and then it's just gases around it. It's basically a giant gas planet. So let's zoom in on Jupiter. And here we're going to kind of move around Jupiter. I'll show you what it looks like in space if you were able to go around it. So let's revolve around Jupiter. And it's got, of course, the great red spot, which is on the dark side right now. We're not able to see that. But it rotates in 12 hours. So every 12 hours you can see the red spot rise. And there we go, the night side. There's the sun facing the sun, and we come out to the light side, which is facing us right now. And it's just one of my favorite planets to look at. Like you see, when you look at it through a telescope, you actually see 4 of the moons. And on a really dark night, you can catch a couple other really tiny moons there. But the 4 moons are pretty prominent. That's going to be Io, Callista, Ganymede, and Europa. And so and then right to the left of Jupiter, we have the planet Saturn, another gas giant, the 6th planet from the Sun. There we go. Now Saturn, like Jupiter's, It's made mostly of hydrogen, helium, and trace amounts of the other elements, but basically just like a star. And Jupiter, same thing, built like a star. The sun's mostly hydrogen with some helium, the same thing with these two planets. And I should say, like Jupiter, if it had like 80 times more mass, it would be a star. It would be a red dwarf star, the smallest stars. But they're made just like stars, mostly hydrogen with some helium. Here we're just looking at Saturn, a very cool planet to see through a telescope as we revolve around. Now the rings are really thin. For the most part, they're about 66 feet thick. And so when they're edge on to us, the rings are invisible. You can't see the rings, and that happened, must have been like 8 or 9 years ago, the rings were edge on to us. And for a few nights, you couldn't see the rings at all. And now they're kind of opening up to us, and they're going to continue opening up to us. And so there's the planet Saturn. It's a beautiful planet to see through a telescope. Everyone should see it in their life. It's a sad thing if you miss looking at Saturn. And we'll just let you look at Saturn here as we move around it. I say it's a very cool planet. All right, and there's Saturn. So let's shift a little more to the eastern sky here, and we'll look at another planet's up there. And there it is, rising right there about 11 o'clock or so, is the planet Neptune. And this planet Neptune. Now Neptune, it takes 164 years to orbit the sun one time. It's a really long orbit. And it's about 2.8 billion miles away from us, which is incredibly far. When you figure a billion, 1 billion equals 1,000 million. When you consider it like that, a billion miles is incredibly far, and this one being 2.8 billion miles away from us. Now, like Uranus, they get their blue color from methane that's high in the atmosphere, methane ices, and the methane absorbs all the colors of the rainbow from the sunlight except blue, and blue it reflects back, and that's what gives Uranus and Neptune its bluish colors, the methane in the atmosphere. But again, it's like Jupiter and Saturn. It's mostly hydrogen and helium, with trace amounts of other elements. So we'll just let it revolve around here. I'll show you what it's like, different views of Neptune there. It's a beautiful planet. And we'll zoom out on that. And let's bring back our night sky. And we'll rotate again. Now here's the blue planet is Uranus. It comes up after midnight right now. And here we'll zoom in on Uranus. Another nice planet to see through the telescope. Now this one, Uranus takes about 84 years to orbit the sun. Now, Uranus is actually tipped on its side, and so for 42 years, one pole is facing the sun, while the other half is dark, and then when it revolves to the other side, the other pole is lit up for 42 years. So one side's in the dark for 42 years, and one side's in the light constantly with this planet. But it is tipped on its side. I'm not really sure how that happened. Maybe a collision with another planet. And so it will zoom around Uranus here. I'll just let you enjoy that for a second. All right, there's Uranus. We'll let that go away. We'll bring back the night sky here. There we go. And now we're going to rotate it towards the north, the northeast. As a lot of great things to see up here through a telescope. And there's a couple of constellations here. The first one is going to be Pegasus. The stick figure will show up. There you go. Pegasus and the Great Square. And on the other end left of that is Cassiopeia. the Cassiopeia, the W of Cassiopeia. You can see that in the sky. And if you go to the top part of the V of that W, which is more prominent than the bottom side, that V points right to Andromeda, maybe about 4.5 inches at arm's length if you follow that arrow from where that top V is pointing of the W of Cassiopeia. It'll point to the Andromeda Galaxy M31. And we'll let that zoom in. And here it comes, Andromeda. So here we are with the Andromeda Galaxy M31. And Andromeda is a giant galaxy. There's about 1 trillion stars in Andromeda. And you can actually see Andromeda with your eyes up in the sky in a dark sky. It's the farthest thing we can see with our eyes, being about 2.5 million light years away from us. And you see the center of the galaxy here. Well, the center is about the size of the full moon in our sky, and you can see it as a fuzzy patch. The whole Andromeda, if we can see the spiral arms too, it'd be about 5 full moons side by side in our sky. It'd be that large. It's, even though it's far away from us, it's a large galaxy. And it's moving towards us at about 600 million miles a second. There's about 1 trillion stars in Andromeda. In about 4.5 billion years, Andromeda is going to come at us, is coming at us now. In about 4.5 billion years, it's going to reach our galaxy, and the two galaxies will collide and form a larger galaxy with a great amount of stars. So that's Andromeda there. All right, so here we are back at the night sky, and this is actually the sky in September. And you see a lot of the planets are going to be lined up. They're all going to be lined up in the night sky in the September, end of August into September, and through the beginning of October. And it's going to be a great sight to see through a telescope, because all those planets lined up. So here we're going to zoom in on a couple. We'll show you, or we'll zoom in on the rest of the planets we haven't seen yet. And the first one's going to be the planet Mars. And there's Mars. And in a second, we'll zoom in onto it. Now, Mars has the red color. You know, it's a red. You'll notice it's a red color in the sky. And the red is actually from iron that's on the surface. And the iron is actually rusted. It's iron oxide. It's rusted. That's what gives the red color to Mars, actually, the rusty red planet. And there's no water on the surface. And there's signs that it may dribble out occasionally. But we think there's a lot of water underneath the surface. Like Mars could be like a snowball underneath there with a lot of water. There's water on the ice caps, even though it's a lot of CO2, which is basically dry ice on the ice caps. And so we're going to revolve around here. Now Mars has some really nice features. It's got a canyon on it, Valles Marineris, and that canyon is 2,500 miles long. It's about 4.3 miles deep, and just a giant canyon on there. And it's also got the tallest mountain in the solar system, which is Olympus Mons. And it's much higher than Mount Everest. And so there's the planet Mars. We'll just let it revolve around. And the next planet we're going to look at is going to be the planet Venus. Our sister world, as they used to say, or they still say it. And they say that because it's roughly the same size as the Earth. And so we'll point it out here. Then we'll zoom in on Venus. Now, Venus is a very bright planet. You see it. I'm sure you've seen it in the night sky. Very bright, and that's because the clouds are really reflective up there. It's got in the upper clouds. It basically has sulfuric acid, which is really reflective. And sulfuric acid, you've heard of that before. It's the same as it's battery acid, and it basically has battery acid in the clouds of sulfuric acid, and it rains battery acid, but it evaporates before it ever hits the ground. Now, Venus has a surface temperature of over 800 degrees, about 867 degrees Fahrenheit. Very, very hot. And then the pressure of the atmosphere, the weight of the atmosphere, it's like being 3,000 feet underneath the ocean. And here on Earth, we feel about 15 pounds per square inch on us. And on Venus, that would be much higher, about 1,380 pounds per square inch. So basically anything that lands on Venus is going to be crushed really quick. The Russians landed a couple of Venera craft on Venus, and they took a few pictures before they were basically cooked and crushed at the same time. So anything that lands on Venus is not going to be there very long, not a place for us ever to visit. So let's zoom out on And then we're going to bring up here is the planet Mercury, the closest planet to the sun. It's about halfway between us and the sun. And we're going to zoom in on Mercury right now. There's being the smallest planet, it's about 3,030 miles in diameter, very small compared to the Earth, which is about 7,900 miles in diameter. It's basically the size of the United States, roughly. The width of the United States is basically the diameter of Mercury. And it's basically tidally locked here. And Mercury is basically a core with a crust, but it's mostly core. They think Mercury at one point was a lot larger than it is now because the core is about the size of the Earth's core, but the mantle and the crust is very thin on it. And they think when it was formed, the sun was very unstable. It was throwing a lot more energy out at that time. They think the surface of Venus might have been as hot as 10,000 degrees. And at that temperature, it just vaporizes the rock. And they think that's where or how Mercury lost its mantle and its crust. It's a lot smaller than it should be. Or the second option, maybe it collided, but probably not. There's really no signs of that. But they think maybe it just evaporated away from the intense heat from the sun. And so there is the planet Mercury. And now here we're going to go to our planet Earth. We're going to spin around here and we're going to take off. Well, actually, we're going to go to the moon. Let's go to the moon first. And so there's the moon right down on the 20th of July. And we're going to zoom into the moon. Now, the moon is basically made of the Earth's crust and mantle. We think, 4.5 billion years ago that a Mars-sized planet crashed into the Earth, and that debris was thrown into orbit around the Earth, and that debris formed the moon. The moon is basically made of the Earth's crust and mantle. And there we go. Of course, we've had 12 men step on the moon in the Apollo days. We talk about going back, which would be a nice thing to do. A lot of things that we could do on the moon. Telescopes, radio telescope on the dark side would be really nice to listen to, see if there's anybody else in the universe or in our galaxy anyways, sending radio waves out. So there is the moon. We're just going to zoom around it a little bit and it'll let you watch that, give you an idea. And we'll rotate. You'll see the Earth coming into view shortly. Now, the moon takes about 29.5 days to orbit the Earth, almost a month to orbit the Earth. There we go there. Then we'll come back, and there's the Earth in the background. And you can see the moon's pretty far away from us. The moon is on average about 239,000 miles away from us. Or to think of another way, it's about 30 diameters of the Earth away from us, which is quite far. We're going to zoom in on the Earth. So we'll center the Earth, and we'll zoom in on our home planet. And goodbye, moon, past the moon, and here comes the Earth. There we go. The lone planet, the only planet we know of with life on it right now. And being the only planet with life, we kind of deserve it to the universe to take care of this planet so we survive for a long time. And being an intelligent species, I think we're very capable of doing that, even though right now it doesn't seem at times the way we're abusing the Earth. But I think that'll be solved over time. And we'll just revolve around the Earth here. I'll give you a view. There's a sun right now from our view. You see the dark side of the moon right now, the night side. Let's let it revolve around a little bit more. There's a quick revolve around there. There we go. And again, our home planet, the planet Earth. And so now I'm going to show you the constellation, what happens, and why the constellations have shifted over the last 1,000, 2,000 years. And it's because the Earth wobbles. It doesn't just point at the North Star. It actually has an 11,000-year wobble where it's wobbling back and forth. If we go back 1,000 years ago, like this scene here, you have Sagittarius is now, the sun's in Sagittarius. But when you bounce back today, the same date at the end of November, you see we're in Scorpio now. And if you look at Libra, you'll see Libra shift to the right, and the whole sky kind of shifts to the right for where it used to be 1,000 years ago and more when they first invented astrology. So everybody's actual sign is now shifted. And you see now, there it is back in Sagittarius 1,000 years ago. And that's why. It's because the Earth's a wobble in space. And so that's why the constellation has changed. And of course, the rules of astrology are, your birth sign is the constellation the sun is in. So like I said, everybody's been reading the wrong constellation. Most people, your actual sign is the month prior to that. Your sign would be your actual sign. So in this next section, I'm going to show you your astrology signs and the constellation signs and where the sun moves throughout the year through the constellations. And you're going to notice there's now 13 signs now. And Ophiuchus is a new constellation that's in. And so here I'm going to bring up the constellations and the lines, and we're going to start moving. You're going to know Scorpio is going to be first. It's only in Scorpio for 6 days as it starts moving here. And basically in Scorpio from November 23rd into November 29th. So it's only in Scorpio really quickly. And then we're into Ophiuchus, which is my son Kevin's sign. And December 6th, it's in Ophiuchus from November 30th up to December 18th. And there's the 18th right there. Next we move into Sagittarius, which is going to be the dates of December 18th. And then it gets out of Sagittarius on January 19th as we move across here. And then we stop. The next one's Capricorn, which is January 20th into February 15th. There we go. And then next is Aquarius, February 12th up to March 10th. We'll let it move through there. Then we move into Pisces from March 11th into April 16th. My daughter Kaylee's a Pisces. Oh, I take that back. She's an Aries. Aries starts April 19th, which is her birthday, up until May 14th. There we go. Now, and then we're into Taurus from May 15th into June 20th. And then Gemini, which I used to be, now is Gemini's June 20th into July 20th. June 21st up to July 20th. Then we move into Cancer, which is July 21st up to August 10th. Then into Leo from August 11th up to September 16th. And then we go to Virgo from September 17th through October 30th. And we'll run through there. And then we're into Libra, October 31st up to November 22nd. So that's your new constellation sign. So everybody's actually reading the wrong constellation for the last 1,000 years. Your sign is actually now, as you'll see, is actually the month before in most cases. Some people are on the borderline, but for most of us, we've been reading the wrong constellation. I personally like being a Gemini, but I'm no longer a Gemini. I'm a Taurus now, so I have to get used to that, along with everybody, I guess. So that's what's going up in the sky with the constellations. And well, I hope you enjoyed this show. Again, my name is Rick Costello. It's produced by Michael Snopoli. I definitely appreciate his help. And again, this is the universe that we live in. I hope you join us next time. And look up is all I can say. Look up. There's amazing things out there. So thank you for joining me. Have a good day.